Hey, welcome. Today we're going to jump right into the amazing world of engineering research. We're going to peel back the layers and see how a tiny little idea, that spark, that aha moment, gets turned into the incredible tech we use every single day. Let's get into it.
I mean, seriously, just for a second, think about the phone you're probably holding or the computer you're watching this on. It didn't just magically appear, right? It all started with a whole bunch of questions and problems that needed solving. So, how do you get from a simple what-ifs to an actual piece of hardware? Well, that's exactly what we're going to break down.
All right, to really understand that journey, we've got to start from square one. We need to build a solid foundation by figuring out what research even means in the first place.
Okay, the absolute key word here is systematic. Research isn't just about randomly being curious about something, it's a structured, organized process. Think of it like this. You've got a garden, and you notice some plants are thriving while others, not so much. Your research wouldn't be just staring at them. It'd be a system. You'd observe, you'd form a hypothesis, you'd collect data on things like sunlight, water, and soil, and then you'd analyze all that to figure out the facts. It's basically a formal quest for answers.
And this is where it gets really cool. This slide shows that research is a loop, a continuous cycle, not just straight line from A to B. It all kicks off with a real practical problem. Let's stick with our garden. Your plants are struggling. That problem motivates you to ask a research question, like, what specific nutrients are missing from my soil? That question then helps you define a whole research project. Your project eventually leads to a result, which, you guessed it, helps solve the original problem. It's the engine of innovation in one perfect picture.
So, how do you get that cycle spinning? Well, it really starts with these 4 essential steps. First, you spot a problem or something we just don't know enough about. Step 2, you nail it down with a super clear problem statement. From there, you break it down into specific questions you need to answer. And finally, you set your objectives. These are your goals, your North Star for the entire project.
Okay, so we have a roadmap, but let's talk about the destination. Why? Why do we even do all this engineering research? What are the big picture goals that are driving all this incredible innovation?
At the end of the day, it really comes down to these 4 heavy hitters. You've got innovation and advancement, that's all about creating brand new things. Then there's problem solving, tackling the real-world headaches we face. Next is optimization, which is just a fancy way of saying, how can we make what we already have even better? And last but not least, knowledge expansion, literally pushing the boundaries of what humanity knows.
And this is where the rubber really meets the road. This isn't just theory locked away in a lab. Researchers are out there, actively trying to find real, practical solutions to the challenges that affect all of us, whether it's on a massive industrial scale, in our own communities, or even in our own homes. And this, well, this is the super exciting part. This objective is all about pure exploration. It's about venturing into uncharted territory to come up with new ideas, new methods, and totally new ways of thinking that pave the way for the next big thing in technology.
But what about the people doing the work? The researchers themselves? What is it that makes them tick? What gets them fired up to tackle these massive, complex problems? Let's take a look at the human side of all this.
So motivation usually falls into one of 2 buckets. You've got intrinsic motivation, that's the fire in your belly. It's the pure joy of creating something, the satisfaction of discovery, or just that nagging need to understand how something works. Then you have extrinsic motivation, which comes from the outside world. You know, things like getting a raise, a better job, or earning the respect and recognition of your peers.
And when you look at what actually pushes researchers, you see it's this awesome mix of both. It could be an extrinsic goal, like getting that PhD, or it could be something deeply intrinsic, like the pure thrill of trying to solve a problem that no one else has ever cracked. Sometimes it's about making a real, tangible difference in the world, and other times it's about earning that respect that comes from doing groundbreaking work.
Okay, so we've covered the what and the why. Now let's dive into the how, because research is not a one-size-fits-all deal. There are different types, each with its own specific purpose and approach. Think of this next part as your field guide to all the different research methods out there. First up, we've got descriptive versus analytical. Descriptive research is all about observing and reporting the facts. What is happening? Think of a biologist discovering a new species and carefully describing its every feature. They're just describing what's there. Analytical research, on the other hand, uses facts that are already out there to ask, why is it happening? It's about making a critical evaluation, like using historical data to figure out why a certain design failed.
Next, let's look at applied versus fundamental. Applied research is all about solving a very specific, immediate problem, like developing a more efficient solar panel.
Fundamental research, though, is all about curiosity. It's about expanding what we know just for the sake of knowing it. A perfect example is Einstein's work on relativity. He wasn't trying to invent GPS, but that fundamental knowledge he uncovered is exactly what makes your GPS work today.
And finally, we have quantitative versus qualitative. And this one is all about the kind of data you're dealing with. Quantitative research is all about numbers, measurements, statistics, anything you can count. Qualitative research is about, well, qualities. It deals with things you can't easily put a number on, like people's opinions from an interview or detailed observations of behavior.
Whew, okay, that was a lot. But it all fits together beautifully to give us this complete picture of what research is all about. So let's do a super quick recap to make sure it all sticks. Let's just boil it all down. So what is research? It's that systematic cycle that turns a problem into a solution. Why do we do it? To innovate, to solve problems, to optimize, and to grow what we know. What's the drive? It's that potent mix of inner curiosity and outside rewards. And how is it done? Through a whole toolkit of approaches, like descriptive, analytical, or applied, each perfect for a different kind of question.
And that pretty much wraps it up. You now have the basic framework for how ideas become the innovations that change our world. So I'll leave you with this one question to think about. As you look at the world around you, what's a problem that sparks your curiosity? What's the first thing you'd want to solve? Thanks so much for watching.